So the first thing we're going to talk about is the idea of a number line. We're going to use that to jump into interval notation and also the Cartesian coordinate system. So what's a number line? Well, like its name implies, it's a line that has numbers on it. Okay. Important things about the number line, it goes forever in either direction. That's what these arrows mean. And we can kind of take a snapshot of our number line that's anywhere at all. So my favorite number is 16. So I could start at 16 and work my way up. Okay, so this particular snippet of the number line goes from 16 to 20. I could also start at 0, that's pretty common, and then work my way in both directions. So I have -1 and 1, 2, and -2, okay? I can build a number line that doesn't count by 1, so notice each one of these goes up by 1. I could build a number line that starts at 20 and counts up by 10, so 20, 30, 40, 50, okay? But the nice thing about a number line is it lets us place numbers, okay? It gives us a way of sort of conceptualizing numbers visually. So for example, on this top number line, if I wanted to show the number 35, right? Well, 35 is halfway between 30 and 40, so there'd be the number 35. Here, if I wanted to show, say, 18.5, well, 18.5 would be halfway between 18 and 19, so there's 18.5. And here, if I wanted to show the number -1, I just place a dot right on top of -1, okay? So number lines are handy for showing numbers, for showing the relative position of numbers. So for example, I can see 20 related to 17. I can see that 20 is larger than 17 because it's to the right of 17 on the number line. Okay, and they let us place numbers. Okay, now that's pretty handy. We don't always have to draw number lines horizontally. So all of those number lines that I drew them horizontally, but there's nothing that says I can't draw a number line vertically. This is still a number line. I'm again going to start at 0, because that's going to be our most common kind of use of our number line, especially when we build Cartesian coordinate systems. Here vertically, here's 0. When I move up, I'm moving in the positive direction, so 1, 2. When I move down, I'm going in the negative direction, so -1, -2. And I can still place numbers on my number line. So for example, let's say I wanted to place the number 3/4. Now that's a fraction. I don't actually have 3/4 on my number line, but I can think about how I would do that. So 3/4 is between 0 and 1. I need to split that area into 4 equal pieces, okay? So there's 1/4, 2/4, 3/4. So 3/4 will be right there on my number line, okay? So I can draw number lines horizontally and vertically. I suppose technically I could draw them in neither one of those, so I could draw like a funny skewed number line. That would be okay too. But for our purposes, we're mostly going to think about the number line as being horizontal or vertical. And here in a second, we're going to put those together to form the rectangular coordinate system or the Cartesian coordinate system. Before we do that, I want to think about another way of expressing numbers, or rather sets of numbers, using a number line. Okay, so I'm going to build a vertical number line. So here's our vertical number line. In this case, it goes from -4 to 4. And let's say I want to express all of the numbers between let's say -3 and +2. Okay. So what if I want to show all of the numbers between -3 and 2? Well, on my number line, it's not too hard to show that. I mean, it's this from here, -3, all the way up to 2. Okay. That's kind of the stuff I'm talking about, or the set of numbers that I'm talking about. Now, a couple of things to think about. Do I want to include -3? Like, is -3 part of this set, or is it just the boundary of this set? Let's say we want to include -3 and not include 2. Okay? Well, we're going to use some different symbols or notation to indicate that. So if we want to include -3, at -3, I'm going to draw a filled in circle. That means -3 is part of this line. If I want to not include 2, then at 2, I'm going to do an open circle. That means 2 is not part of this. So this is the set of numbers, -3 to 2, including -3, but not including 2, okay? Now, that's pretty handy. There are a lot of numbers included on this line. The number -3 is included, -2, -1, 0, 1. But there's even more numbers than that. So for example, the number 1/2 is included, and the number 1.5 is included, and the number -1/4 is included. In fact, there's infinitely many numbers that are included on this line here, because there's infinitely many fractions that live between any two of these numbers. Okay, so this is how we'd say this in words. All numbers between -3 and 2, including -3 and not including 2. We can show a picture. This is a number line picture or a graph of this. We also want a shorthand way of saying this, okay? Mathematicians, we like to think that we're very efficient. That's a shorthand way of saying lazy, right? We want to be able to show this very quickly. It's not super efficient to draw a number line with the graph. It's not super efficient to have to write all of these words. Plus, most mathematicians, myself included, have terrible handwriting. That's a stereotype. I probably shouldn't propagate that. So one way that we can do this is we can use what's called interval notation. Okay. Interval notation is basically shorthand for showing this blue line or showing any kind of set of numbers. So interval notation says I'm going to take the first number, -3, comma, to the top number, 2. So this says I'm going from -3 to 2. That's what this little comma means. And then we're going to use symbols on the end that tell us whether we're including the endpoints, -3 and 2, or not. -3 is included, okay? When we include something, we use a solid dot, and then we use a bracket, either a left bracket or a right bracket. So I'm going to include -3, that's going to be a bracket. At 2, which is not included, that's the open circle on our graph. And in our interval notation, we're going to represent that with parentheses. So this bracket -3, comma 2, parentheses, means all numbers between -3 and 2, including -3, but not including 2, okay? Phew. All right, let's do another example. So I'm gonna put another number line up here. I'm gonna start this one at 0, and let's see, let's count this one by 2s just for fun. So 0, 2, 4, 6. And if I put, let's see, let's go from 2, not including 2, all the way to 6, including 6. Okay. So what are we showing here? We're showing all numbers from 2 to 6, not including 2, but including 6. So 4 is a part of this set of numbers. 0 is not a part of the set of numbers. 100 is not a part of the set of numbers. How would I write this in interval notation? Well, my numbers, I go from 2 to 6. So from 2 to 6. I have an open circle at 2. That means 2 is not included. Not included is a parenthesis. I have a closed circle at 6. That means 6 is not included. Sorry, 6 is included, excuse me. So that's a bracket at 6. So here's the interval 2 to 6, not including 2, but including 6. Okay? Now, sometimes we want to go the other direction. So we've so far taken a number line with kind of a graph on it and translated that into interval notation. What if we're given an interval and asked to sketch a graph? So let's try and sketch 4 to 7. And notice that I used parentheses on both of those. That means neither one of them is included. So if I want to sketch a number line, I know that my number line needs to include the numbers 4 to 7. So maybe I'll start at 3 and count it by ones. 3, 4, 5, 6, 7, 8. Okay. I want all numbers from 4 to 7. A parenthesis means 4 is not included. Parenthesis means 7 is not included. So this would be all numbers from 4 to 7, not including 4 and not including 7. Okay? All right. One last little twist with interval notation is what if I want to say something like all numbers bigger than 16. So what if I want all numbers bigger than 16? Well, I can draw my number line to show that. So let's see. What if I do 0, -8, -16, 8, and 16? Okay. If I want all numbers bigger than 16, that means I'm going to start at 16 and I'm going to go forever. That line's never going to end because I want all numbers bigger than 16. So that arrow shows me that this line is never going to end. Now here, a little bit of subtlety. I want all numbers bigger than 16. This implies strictly bigger. That means 16 is not going to be included. So I'd use an open circle. Another way of writing this in math speak would be all numbers, we'd say x, such that x is bigger than 16. So x bigger than 16. Okay. Now how would I write that in interval notation? Well, with interval notation, we work left to right, or if we have a vertical number line, bottom to top. So I start at 16, comma, and then where do I end? Well, this arrow means I never end. How do we say that in math speak? Well, in math speak, that's infinity, right? Meaning I'm going on forever. So I can use the infinity symbol. And now let's talk about endpoints. Remember that a parenthesis means included, a bracket, which you can't really make with my hand, means not, sorry, I just said that backwards. A bracket, I'll just write it, a bracket means included, and a parenthesis means not included. Okay. Well, 16 is not included, it's an open circle. But what about infinity? I don't have an open or closed circle here, I have an arrow. What does that mean? Well, we're always going to use a parenthesis for infinity. Why? Well, because included, a bracket, a solid circle, right, means that I can actually get there. I can actually get there and stand on that number. I can never actually get to infinity. It's an abstract concept. I keep walking along my number line forever. So we're always going to use parentheses to indicate infinity. Okay? All right, let's try one more example with infinity. Let's say I wanted to show all numbers less than or equal to -1/2. Okay. So I want all numbers less than or equal to -1/2. Well, I could think of this using a mathematical sentence or a mathematical kind of phrase. That would be x, all numbers, less than or equal to, this is our less than or equal to, -1/2. I could show this on a number line. I'm going to use a vertical number line just to keep us thinking. Okay. I'm going to put 0 in the middle, -1 and 1. -1/2 would be right between 0 and 1. So here, and then I want less than, so that means all numbers less than, I'm going to go towards negative infinity. I started with an open circle, but do I really want an open circle? Less than or equal to, that means -1/2 is included. Okay. So here it is on a number line. This is -1/2 and all numbers smaller than that. How would I write this in interval notation? Well, I'd start, here's where it gets a little interesting. When we do interval notation, something that's really important to remember is we always write the smallest number first and then the biggest number. Smallest number, biggest number. On our number line, if we have a horizontal number line, that means we're working left to right. If we have a vertical number line, it means we're working bottom to top. So here, I've got two numbers or two things involved. I have -1/2 up here at the top. And down at the bottom, right, I have the idea of negative infinity. Which one is smaller, -1/2 or negative infinity? Well, negative infinity is smaller. So that's going to go the first number in my interval. So negative infinity, comma, -1/2. That shows this line, negative infinity to -1/2. I never include infinity. It's always a parenthesis. I can't actually get there. And in this case, am I going to include -1/2? Well, it's less than or equal to. Less than or equal to solid circle. It's included. So there's our interval that shows all numbers less than or equal to -1/2. Also x less than or equal to -1/2. Another way of saying that. We've shown it on a number line and we've graphed it. Okay. Wow, that's a lot with number lines. That's an introduction to interval notation. Last thing I want to do is I want to look at what happens when I take two number lines and I put them together. I'm going to take a horizontal number line, okay, and a vertical number line, and I'm going to put them together. When I do that, I get this nice thing known as a Cartesian coordinate system or a rectangular coordinate system. Now these two number lines meet up at 0. Okay, so I'm going to put some numbers on here. 1, 2, 3, -1, -2, -3. So there's the numbers for my horizontal number line. That means that 0 is right here where these two cross. And then for my vertical number line, 1, 2, 3, -1, -2, -3. Okay. So this is what's known as a Cartesian coordinate system or a rectangular coordinate system. Now what's really nice about a rectangular coordinate system is we can use it to place points in two-dimensional space. What do I mean by that? Well, let's say I have this point right here, and I want a way to reference that point, or in other words, say where it is on the plane of the board, where it is. Okay. Well, I can use our Cartesian coordinate system to do that, right? This point looks like it's falling at 2 on the horizontal number line and 3 on the vertical number line. That's a nice way to reference this point. I can say this point is at 2, 3. Now, this is what's known as an ordered pair. This is different than an interval. This is not the interval 2 to 3, not inclusive. This is an ordered pair. This tells me I'm going to horizontally move +2 and vertically move 3. That gives me the location of that point. In other words, if I start at the origin where these two cross, 0, 0, and go 2 to the right, or 2 in the positive horizontal direction, and 3 in the positive vertical direction, I get to that point. Okay, that's an ordered pair. It gives us direction in space. Let's think of another one. What would the ordered pair -3, 1? What would that tell us? That tells us to go left 3. So I start at the origin and go left 3. 1, 2, 3, and up 1. So this would be the point -3, 1. Okay. Let's do one more. What if I was asked to do the point 1, let's do -1/2, -3/4. Okay. Oh no, fractions, that's okay. What does this tell us to do? It tells us to go to the left 1/2. Here's 1/2, right? 1/2 to the left, or -1/2 is between 0 and -1/2. And down 3/4. Well, 3/4, right? Here's 1/4, 2/4, 3/4. And then my point would be at the intersection of those two. So here would be the point -1/2, -3/4. Ordered pairs allow us to place points in this two-dimensional space. Okay? All right. One last thing, when we're talking about the Cartesian coordinate system, is some labeling things. Notice that our Cartesian coordinate system splits up space into kind of 4 quadrants. Quadrant 1, 2, 3, and 4. Okay? So this is, again, quadrant 1, and we're going to use Roman numerals. So here's quadrant 1, this piece of space. Here is quadrant 2, again, using Roman numerals. Here is quadrant 3. And this would be quadrant 4. Okay. So quadrant 1, 2, 3, 4. We're going to talk a little bit more later about some special points here. So for example, if a point is on this axis here, this is known as the x-axis, and we call that point an x-intercept. This is known as the y-axis. If a point is living on the y-axis, we call that a y-intercept. Okay? So that's just a brief introduction to number lines, interval notation, and also our Cartesian coordinate system.